class is me, Mr. Morris, and we're going to do some notes on quantum numbers. Now, a quantum number is, the quantum numbers are a set of numbers that tell us about the position of electrons in an atom. So really, this is kind of an expansion on electron configurations and orbital diagrams. So this is basically the set of notes that you have, and I'm going to walk you through it, and then we're going to do some example problems. So the notes give us the quantum numbers. You have 4 quantum numbers. The first quantum number is N. That's your principal quantum number, and it's the energy level. So that's most directly going to relate to the row that the element is in. Then you've got L. That's your angular momentum quantum number. That is most directly going to relate to the sublevel that you're in. So you have one quantum number for S, one for P, a different number for D, and then F. And then ML is going to tell you which orbital it is in. So for S, there's only one option. For P, it could be in any of the 3 orbitals, and then D, it's got 5 different options. And then for F, there are 7 possibilities for this quantum number. And then MS, and by the way, you don't need to know what the numbers are called, but the last quantum number is the spin quantum number, and it's going to have a value of 1/2, either positive or negative. Positive 1/2 means it's the arrow that's pointing up. Negative 1/2 means it's the arrow that's pointing down. All right. So let me clear the ink on the slide really quickly. And we'll talk through an example. So first of all, our descriptions, the energy level, that's in our analogy, in our building analogy. That's like saying we're on the 3rd floor of the building. Okay, that's the energy level. On the 3rd floor, there are different wings. At Creekview, we've got the E wing and the C wing and so on. The E tower or E wing is the sublevel. And then our orbital would be like the room number that we're in. And then within the orbital, you've got which exact seat that you're in. Okay. And then we've got our possible numbers. So the electron location, the energy level that the electron is in, is what the first one gives us. It's usually the period, but remember for the D sublevel, N is going to equal whatever the period number is minus 1, so it's 1 less than the period number. And for the F sublevel, it's 2 less than the period number. The sublevel, for S, we're going to put 0. For P, we put 1. For D, we put 2. And if it's an F sublevel, we would put the number 3. The orbital, the central orbital is always 0. So if we're talking about just in an S sublevel, there's only one orbital, so it's always 0. For the P sublevel, 0 is in the middle, and we have a -1 on the left, a +1 on the right. And then it's just like a number line. For D, we have -1 and -2 on the left, +1, and then +2 on the right. And then for F, -1, -2, -3 on the left, +1, +2, +3 on the right. And then, as I said, an up arrow is +1/2, down arrow is -1/2. So that's how we get our 4 quantum numbers for an electron that we're describing. So in this example, for boron, we want to look at the very last electron in boron. So if we were drawing the orbital diagram, we would go 1s, 2, 2s, up and then down, that would be 2, and then we get to 2p, that first electron is right here, or the last electron is right there, 2p1. So what we want to do is describe that electron. It's in the 2nd energy level. So we put the number 2. It's in the P sublevel. So we would put 1 because P is represented by the number 1. S would be 0, P is 1. If it was in a D sublevel, we would put 2, and if it was an F sublevel, we would put 3. And then we want to look at what box it's in. So remember, the one in the middle is always assigned 0. Then we have -1, and then we have +1. So this is on the left side. It's in that box, so that gives it the -1 value that we have here. And because the arrow is facing up, it's a +1/2. All right, let's go through some examples on the next slide. In this case, it specifically says to determine the quantum number for all of the valence electrons in chlorine. So this is a little bit different. All of the valence electrons in chlorine, so that's all of them that are in the 3rd energy level. Okay, we've got our noble gas configuration written there. And we could write it out as a orbital diagram, 3s2, 3p, 2, 4, 5, 3p5. Okay. Now I've highlighted these because we're going to describe each of these in order. The first electron we come across is the up electron in the s orbital. And remember, this s orbital, the 3s, is 0, and then we have the 3p sublevel. 0 is in the middle, then we have -1 on the left, +1 on the right. These are the quantum numbers that you would get for this. 3, 0 for S, 0 again because it's on that central orbital, and then +1/2 because it's the up arrow. The next electron is this blue one that is facing down. 3, 0, 0 again, but this time it's a down arrow, so that's -1/2. Our next electron is the up arrow right there in the p sublevel. So to describe that, we would say it's 3 because it's in the 3p sublevel. P is not 0 but 1, and then we need to decide which orbital it's on. It's on the one to the left, which is assigned a -1. And it's an up arrow, so that would be +1/2. So that's what we get, 3, 1, -1, +1/2. All right, now if I was drawing this electron configuration and I was doing my p sublevel, I go up, and then if I did that, I would be wrong. Okay, so that's not the way we would draw that. We don't jump straight to the next down arrow here. Remember, Hund's rule says that we need to have one up electron in each orbital in that p sublevel before we have any down arrows. So the second one is actually going to be the orange, or I'm sorry, is going to be the yellow arrow. Okay, so that's the next one we want to describe. So it's still in the 3p, so it'll be 3, 1. In this case, it's on that 0 orbital, and it's up, so that'll be +1/2. So 3, 1, 0, +1/2. The next electron would be up again, and it's that green arrow. 3, 1, +1, because it's over here, and then +1/2 because it is an up arrow. And then we're going to go back to the next down arrow, which would be the purple one. So that will be 3, 1, and it's -1 because it's on the left, and it's down, so that would be -1/2. And then finally, the last one is the pink arrow. That'll be 3, 1, because it's still 3p, and down on the 0, so it'll be 0, -1/2. All right, so we want to do a different type of problem here. It says to determine the quantum numbers for the last electrons for the following elements. So we find Mg. So what we want to do is write the electron configuration for magnesium, and we can just do the noble gas configuration. So that would be neon in brackets, and then 3s2, neon 3s2, and then we'll draw the orbital diagram for it. I'm sorry, it says 1s2 here. It should say 3s2. That was a mistake. But it should say 3s2. In fact, let's just cross that out and fix it. That should say 3s2. So that gives us a different quantum number than what I have here. This should be 3. And then S is the 0 sublevel. So because it's S, that tells me it's 0. And then we draw the orbital diagram. We have the up arrow, the down arrow. Remember, the central orbital is always assigned a number of 0, and then negative 1/2 for a down arrow. Let's check the next one. Silicon. All right, I'm looking at my periodic table right now. Silicon's in the 3rd row, the P block, and it is the 2nd element. So that would be 3p2 is how it's going to end. 3p2. So 3 tells me the first quantum number. P tells me it's going to be 1, because remember, it's S is 0, P is 1, D is 2, and F is 3. So they go in order S, P, D, F for the 2nd quantum number. Our 3rd quantum number tells us whether it's on the central orbital, on the left, or on the right. It's on the central orbital, so that's a quantum number of 0. And by the way, if you didn't follow Hund's rule, you'd get the wrong answer for that. And then finally, it's positive 1/2 because it's an up arrow. All right, Kr. Krypton is 4p6 is how it will end. If you look at the periodic table, it's in the 4th row, the P block, the 6th element in that block, 4p6. And if we fill out the orbital diagram, that gives us 2 electrons in each orbital, and the last electron we drew would be the down electron on the last orbital to the right. So that gives us 4 for the energy level, 1 because it's a p sublevel, positive 1 because it's on the right, and then negative 1/2 because it's a down arrow. Then we get to cobalt. Now cobalt is in the D block, and don't forget, D is weird. So cobalt's in the 4th row. But remember, since it's in the D block, we don't say 4D, we say 3D. So our energy level will be 3D. So our first 2 quantum numbers are going to be 3, and then D is 2. So it'll be 3 and then 2. We know that from this information. We know the first 2 quantum numbers. Then we have to draw the orbital diagram to come up with the last 2. So 3d7 would be 1, 2, 3, 4, 5, and then we go back with the down arrows, 6, 7. So the last electron was on the negative 1 orbital, and it was down, so that gives us a negative 1/2 for the final quantum number. All right, for titanium and I think that's promethium, PM, I'm going to go ahead and just work through this, just writing out a little more shorthand how I would do this. Okay, so titanium, if I found that on the periodic table, that's in the 4th row. It's in the D sublevel, and it's element number 22, by the way. So it would be the 4th row, we call that 3d2. So it ends in 3d2. Of course, that's not the full electron configuration, but that is enough to get us to get our answer. Okay, since it's a D sublevel, we can go 1, 2, 3, 4, 5, and my middle orbital is right there. That's 0. Then I'd have negative 1, negative 2, positive 1, and positive 2. Since it's 3d2, I would do an up arrow here. Don't go with a down arrow right next to it. We have to have 1 up arrow in each of these before we go down with our second down arrow, or with our first down arrow. Okay, so 3, and then D is 2, S is 0, S is 0, P is 1, and D is 2. And then my next number is -1, and it's an up arrow, so that's +1/2. All right, PM is in the F block, and it's in that 6th row. So it's the first row of the F block, which is the 6th row. But remember, with F, we go down 2. Instead of being 6F, we say 4F. So it's 4F. And if I were to count over, I get 1, 2, 3, 4, 5. It's the 5th in that particular section. 1, 2, 3, 4, 5, 6, 7, because the F sublevel has 7 orbitals. Our middle orbital is going to be right here. -1, -2, and -3. And then I should have +1, +2, +3. Okay, for F5, I'm going to go up, up, up. That's 3, 4, 5. So I have 4 as my first quantum number, the energy level. F is 3, so S is 0, P is 1, D is 2, and F is 3. So 4, 3, and then +1, and it's +1/2 because it's an up arrow. All right, let's go to the next slide. And we've got the first one worked out with those colors, color-coded. The rest of them we can work through just writing it out. Identify the elements whose last electrons have the following sets of quantum numbers. Remember, the first quantum number tells us the energy level. So 3 is my energy level. The second one tells me, and actually let me erase that because I think that I've got this already on the slide. Okay. So 3, and then the second one is P. Now we don't know what that number is yet. Okay, it's 3P something. But we've got the 3 and the P from the first two quantum numbers. To find the others, we're going to have to write out the orbital diagram. So it would be, we're going to have a P sublevel, that's 3 lines. And it looks like our last arrow is going to be on the one on the right, on the orbital on the right, with an up arrow. Okay, so the green quantum number told me it's on this orbital. The blue one told me it's an up arrow. Now I can count my electrons. 1, 2, 3. That's 3p3. Okay, now we could find that on the periodic table. Go to the third row, the P block, and find the third element, that is phosphorus. All right. Now let's do the next few. I'm going to actually pause the video here and let you guys try a few of these. You can check your answers with the next video, which is just example problems.